Right now we are using the pop curve force to make our these particles follow along the line. And in here we also have another node that is called the pop curve incompressible. If you type pop curve, and in here we have this pop curve incompressible flow. And if I were to add this, and this force node, this was designed to work with the flip simulation to control the particles behavior of our fluids, our water. But we can also use this to control our this normal particles simulation as well, because it is an a pop node. It is designed to work with particles, so there is no reason that we cannot use this with the particles simulation. So in here I'm going to just remove this pop curve force, and I'm going to just use this first. We need to go back at the very first frame, and let's connect this in between in here. And in here onto this pop curve incompressible flow, we need to define the geometry source, and right now it's set to SOP, which means I can just pick my line location, or I can just change this to second context, because we have our line in the second context, and there we have it. And in here let's play this as is, and here as you can see we have particle movement. Our particles are moving, and right now here as you can see they are following the path accurately, but right now they're moving slow. So what I can do, I can in here increase the velocity scale, and to the parameter we have the velocity. In here let's increase the velocity scale. I'm going to just increase this to some value, some higher value, and let's hit play again. And here as you can see we have these particles. Now they are moving fast, and they are adhering to our curves better, and they are following our this path a bit better, and they are also preserving their volume. And in here as you can see these particles are moving incompressible way, which means they are trying to keep, these particles are trying to keep their separation. They're not getting stick together, they're not getting too close with each other. And in here we have the angular velocity, and what that will do, it will try to get the angle from our this line. And if I were to enable the angular velocity, and let's hit play, and here as you can see at these we have banking, and our these particles will follow this same banking as we have onto our this line. And I think it might be better visualized if I were to just go back, and in here let's play around with the orientation of our this circle. And in here I'm going to just change its orientation. Right now we are orienting at the XY plane. I'm going to just change this to ZX plane, and right now we have this laying flat onto the ground. And maybe let's play around with its center value, and I'm moving this in here onto this axis. I'm going to adjust the Z axis as well. So we are right now far away from our line. And now let's go into the top net, and here as you can see if I were to hit play, and here as you can see as they are following the line, they are also, these particles are also adopting its curvature, its angle. And it might be better if I were to just increase the angular velocity scale to exaggerate the value. And in here I'm going to just lower down its following velocity scale, and I'm increasing this angular velocity. Let's hit play again, and here as you can see because we have a very higher value, and they are just following, getting these angle, and our this simulation is getting this, we are getting this organic looking particle movement. And maybe let's lower down its angular velocity scale, because I think that value was too high. And to maybe better compensate this, I need to go into the velocity. We need to go back at the very first frame, and let's increase the velocity scale and hit play again. And here as you can see, we have these following animation. And in here as you can see, we have this bending. And if you take a look at these particles, we have this ribbon type animation. And in here, let's maybe convert these particles into mesh. And right now we have these particles, and to actually convert out these particles into mesh, we can say particle fluid surface. Let's add in here, and we have the particle fluid surface node. Let's add this, and that node is used to mesh the particles, and that is used with the flip simulation. We simulate the flip particles, and then we will convert all of the flip particles into mesh for rendering, and that node is used for meshing. And we will talk about this node later, but right now just connect this into the first input and let's visualize this, and that will just convert your input particles into mesh. And here you can see, if I rewind and hit play, and now our particles has been converted into mesh. And by using this node, and here you can see, we can create this organic splashes, and we can art direct our splashes, or we can create any growth system, organic growth system with this pop curve force. Let's dive inside the .NET, and right now it is in a slow operation because this particle fluid surface needs to compute the mesh on every frame, and that's why this animation was getting slow, but that is an expected behavior. Let's go back onto the .NET and dive inside and onto the pop incompressible, this node. Let's take a look at some other parameter that we have. And in here we have the velocity along length, which means we can play around with this ramp to control this force behavior with the ramp. And we have the angular velocity, and in here same thing, we have this ramp to control all of these forces scale along the length of our line. And onto the shaping, we have this resample. The default resample is fine. And onto the treat as wind, we can enable this to treat as wind. Right now this force is acting as an acceleration force. Let's maybe enable this treat as wind, and let's view. And right now, by enabling this treat as wind, it's not working. Maybe let's lower down the air resistance. And I think that this will work when we are using this with the flip, and with this popnet, this treat as wind is not working, and only it's working as only as an F force. But that is an A pop incompressible flow node.